waves when they come up against boundaries. And so I have some words here, but I also want to bring in some animations. So just give me a second, okay? So let's talk through the words first. A pulse reaching the end of a fixed-ended medium becomes inverted whenever it reflects off a fixed end. So I want to underline this idea of a fixed-ended medium and inverted when it reflects off of that fixed end. Let's look at a video for this, because if I have a pulse that reaches a free-ended medium, it does not become inverted when it reflects off of that free-ended medium. I want to pull over some media that are either fixed or not fixed. Let's see what we can see here. If I were to say this one here reflects off of the end of a medium, the pink line, let's just say, is like a, I don't know, like a slinky or something. Is this one inverting or not inverting? This one is inverting. So which one are we talking about? Is this the fixed end or the not fixed end? Fixed, yeah. If I scroll down to this guy here, let's see what happens. Oh. Fixed or not fixed? Not fixed. And when I think about a not fixed end in my everyday life, I think about, like, the bathtub. Like my kids are older now, but there was a time, we all had a time when there was bath time, right? You imagine like the edge of a bathtub, the water sloshes up against the edge and it comes back down again. It's not fixed at the edges. If it was fixed at the edges, then we would be talking about, I don't know, like, you ever see like a bowl full of pudding? Like homemade pudding, there's like a pudding skin on the edge of it. That's stuck to the edges of the bowl. Maybe less like food-wise and more musical. A drum, the edge of a drum, like the membrane on a drum that vibrates, it's fixed around the edges. Those are fixed edges. When I think about a guitar string, like the top picture, is fixed at one end, right? We talk about the tuning pegs at one end. We talk about the fretboard maybe, and your finger might hold it down at a point on the fretboard to make it be fixed. A piano string fixed at both ends. Okay, so free-ended waves versus fixed-ended waves are things that we can picture, whether it's bathtubs or guitar strings. We've seen fixed-ended strings on guitars. We've seen free-ended bathtub waves. Okay, if you ever had a fixed-ended bathtub wave, that would be weird. You imagine all the way around the perimeter of the bathtub, the water level doesn't change. It just kind of like vibrates in the middle. That would be wacky stuff, right? And so we know that we've seen these things, and it would look weird if the wrong kind of endedness happened. So here we got free end, sloshes up against the edge, sloshes back again. We have fixed end, inverts upon reflection. Let's see what these other options are. Ooh, what if there was another medium? You see that if one medium butts up against another medium, there's transmission into the secondary medium. There's still reflection into the primary medium. And when I look at a wave like this, I think, immediately my mind goes to fishing. Doesn't yours? Mm-hmm. You imagine when you go fishing, people always say, be quiet, you'll scare the fish. Do fish have ears? I don't think so. I bet you they can sense sound. I bet you that's the thing. They can sense sound and vibrations, right? They're animals. Why not? If you're loud, if you turn this picture sideways, can you imagine being loud above the water? Those vibrations get transmitted into the water. And those transmissions going into the water are going to scare the fish. That's bad if you're a fisherman, right? But notice this. We'll reset it. Notice that the reflected wave gets inverted. The transmitted wave doesn't. Transmitted wave actually never gets inverted. That's weird. Undisturbed reflected pulse. I think we're not going to do the undisturbed reflected pulse. But this transmitted wave, I think we have to go a little bit deeper on this too. So let's get rid of this thing. Bring it over here. Let's carry on. All right, so we have this idea of a fixed, I'll write the word fixed at the top of this column and unfixed at the top of this column. And we just watched the animation, but this is my cartoon strip of what we just watched. I've got a wave traveling towards a wall. It hits the wall and it reflects back, but inverted. That's fixed-ended reflection. How could we do this? Honestly, take a skipping rope and attach it to a pole. Tie it to a pole. You can send the skipping rope pulse down and it'll come back inverted. How else could you do it? Hey, we're going to play with slinkies in the hallway. Send a pulse. I mean, I demoed it earlier, but you'll get a chance to do it with a friend too. Send a pulse that's positive. If the friend holds their hand still, it'll reflect off of your friend and it'll reflect back inverted. Okay, guaranteed. How do you do an unfixed? Well, this one is trying to show that if I have a string, you imagine this is like a ring. In my mind, I think like a carabiner. If I attached a string to a carabiner and that carabiner was free to slide up and down on a rod, or if I lay the rod flat on the floor, like horizontal, can you imagine that the carabiner could slide back and forth on that rod? That would be unfixed because the carabiner is not tied in place. It's by design allowed to slide, right? So this is an unfixed end. It turns out that the reflection isn't going to be inverted. So could we do this? 100%. We could attach a carabiner to a rod and attach the carabiner to a spring and send a pulse. It'll send back a non-inverted reflection. Totally. This is a thing that we could do mechanically. We also saw it in the animation. So characteristics of a transmitted pulse. A pulse and a wave carries energy through a medium from one location to another. But when the pulse reaches the end of the medium, where does the energy go? All right, so we actually saw that in the animation. Energy doesn't disappear. It can actually pass into the new medium. That's what happens. Now, does some of the energy reflect back? 100%. That's why when I yell at the water, the fish are going to get scared. But if I yell at the water from a bridge, don't you believe that I would hear an echo coming back up off the water? Of course you would, right? So yeah, some we say we have partial transmission and partial reflection. Some of the energy gets transmitted in to the new medium, some of it gets reflected back. It takes more energy to move a more dense material. Well, that makes sense. I mean, if I was thinking about, I don't know, here I have a illustration that I stole from a textbook. If I have a little tiny string attached to a great big thick rope, the great big thick rope is harder to move. The little tiny string is easier to move. And so when this little tiny string, which is, let's just say that it's tied to the big thick rope, when it hits the big thick rope acts like a fixed end and it sends back an inverted pulse. But it still transmits some of the energy into the big thick rope. This is our analogy for transmitting energy from one material to another. Whether I'm yelling at fish with sound or sending like a jerked wave pulse with two strings tied to each other, it's the same idea. Are you guys buying what I'm selling? Okay. So I try to show it with animation first because I think if I don't show it with animation, the illustrations aren't as meaningful. Do you think I'm right on this one? Some nods of the head? All right, good. All right, so not all the energy gets transmitted. We think about echoes. We think about that partial reflection. And so we could say, in conclusion, the boundary behavior of waves is best summarized by the following statements. All right. Some energy transmits. Some reflects. The wave that reflects only inverts if the secondary medium, is harder to disturb. Oops. Harder to disturb. And the example we use is of a thin rope compared to a thick rope. We got a few math facts here, or sorry, wave facts. The wave is easier to produce in the less wave dense medium. And so this is a bit of a vocabulary thing. A less wave dense medium means that it's a medium that's easier to make a wave in. Fact 2, the wavelength is always greatest in the fastest medium. Maybe I should add words into this. Easier medium to disturb. With waves. Okay, so the easier material to disturb with waves. That's the less wave dense medium. Fact 2, the wavelength is always greatest in the fastest medium, and the frequency of a wave is not altered by crossing a boundary. We've actually talked about that before. So we could say frequency not altered. See the marching person in earlier note. And then fact 3, the reflected pulse becomes inverted when a wave is in a less dense medium is heading towards a boundary with a more dense, that's harder to move medium. Fact 4, well, maybe I should say acts like a fixed end. And then fact 4, the amplitude of the incident pulse, incident means incoming, so this would be the incident pulse coming towards a material boundary. The amplitude of the incident pulse is always greater than the amplitude of the reflected pulse. Notice that if there's energy being transmitted into the secondary material, then less energy is going to bounce back. And really, this is a conservation of energy statement. So we can say energy gets split into reflected energy and transmitted energy. And really, this is just energy conservation. So I think about how much energy is being reflected, how much energy is being transmitted. The sum of those two values would be the amount of energy that was originally incident upon the medium interface. So when I'm going from a slower medium to a faster medium, from a more wave-dense medium to a less wave-dense medium, we say it acts like an unfixed end. That interface acts like an unfixed end. And then conversely, when I go from a low wave-dense medium or a faster medium to a high wave-dense medium or a slower medium, we say that it acts like a fixed end. Acts like a fixed end. I'm going to pause for questions. Anybody got any questions they want to ask? There's no math here. It's very patternsy kind of stuff. Does this kind of make sense to people? I'll pause.